December 1941. Harry Antes stood in the loading bay of the A.C. Gilbert Company factory in New Haven, Connecticut, watching workers pack the last shipment of Erector sets before Christmas. The metal construction toys, miniature steel girders, wheels, motors, and gears that let children build bridges, cranes, and buildings had made Gilbert a fortune and turned him into one of America's most successful toy manufacturers. Then the radio in the factory office crackled with news from Pearl Harbor, and everything changed. Within weeks, federal officials arrived at Gilbert's factory with orders that seemed absurd. Stop making toys immediately. Convert the entire facility to war production. The United States government was commandeering toy factories, turning them into weapons manufacturers. Gilbert was informed that his factory would now produce components for proximity fuses, the most secret weapon development project in America after the atomic bomb. Gilbert listened to the orders, then did something unexpected. He refused. Not because he was unpatriotic, not because he valued profits over victory, but because Gilbert understood something the government officials didn't. His toy factory was already a weapons plant. It just happened to disguise its output as children's playthings. What followed would become one of the most remarkable stories of World War II industrial mobilization, a story deliberately hidden for decades, involving toy companies that designed weapon systems, board game manufacturers that created escape maps, children's book publishers that trained spies, and a nationwide network of seemingly innocent businesses that formed a secret industrial army producing everything from proximity fuses to reconnaissance equipment. This is the untold story of how America's toy makers helped win World War II, not by stopping toy production, but by leveraging exactly the skills that made them successful toy makers in the first place.
By January 1942, America faced an industrial crisis of unprecedented scope. The nation needed to produce more weapons in 4 years that had been manufactured in all previous American wars combined. Factories needed to be converted, workers trained, supply chains established, and quality maintained, all while fighting enemies on 2 oceans who had years of head start in military production. The challenge wasn't just quantity. Modern warfare demanded technologies that didn't exist in civilian industry: radar systems, proximity fuses, precision optics, fire control computers, specialized electronics. These technologies required manufacturing capabilities and expertise that traditional heavy industry didn't possess. The War Production Board, established to coordinate industrial mobilization, faced a dilemma. Converting automobile factories to produce tanks and aircraft made obvious sense. Both industries worked with metal fabrication, engines, and complex assembly. But what about the specialized components? Who could manufacture the intricate mechanisms inside a proximity fuse? Who had experience with precision miniature assembly? Who understood how to mass-produce complex devices cheaply enough to be expendable? Someone at the WPB realized the answer was sitting in plain sight, disguised as children's entertainment. Toy manufacturers possessed exactly the skills modern warfare demanded. They specialized in precision miniature engineering. They mass-produced complex mechanisms from cheap materials. They had perfected quality control for products that needed to work reliably despite rough handling. They understood how to simplify designs for efficient manufacturing. And critically, they knew how to make things cheaply enough that middle-class families could afford them, precisely the economics needed for weapons consumed by the thousands. The A.C. Gilbert Company made Erector sets from precision-stamped steel parts that fit together with tiny screws and bolts. The manufacturing tolerances required to ensure that parts from different production runs would be compatible were comparable to those needed for military hardware. Gilbert's workers could stamp, drill, paint, and assemble small metal components faster and more accurately than most machine shops. Parker Brothers, maker of Monopoly, had printing capabilities that could reproduce complex maps and documents with perfect fidelity. Their experience with multicolored printing on various materials made them ideal for producing maps, training documents, and specialized materials. Lionel Corporation, manufacturer of model trains, had expertise in miniature electric motors, metal stamping, and precision assembly. Their trains required reliable electrical systems, precision gearing, and durable construction, all skills transferable to military applications. The ideal toy company specialized in precision molding of various materials. Their experience making dolls and toys from different plastics and composites gave them expertise in material science that few other industries possessed. These capabilities weren't obvious to traditional military procurement officers who thought in terms of steel mills and machine tool factories. But someone understood, and in early 1942, representatives from the Office of Strategic Services and the National Defense Research Committee began making quiet visits to toy companies across America. When Harry Antes Gilbert refused to stop making Erector sets, the government officials thought he was being difficult. Gilbert explained his position carefully. His factory was uniquely equipped to produce precision miniature mechanical assemblies. Converting the entire facility to military production would waste months retooling, retraining workers, and establishing new supply chains. Instead, Gilbert proposed something more efficient. Keep making Erector sets using existing equipment and trained workers, but redesign the Erector set components so they could also serve as parts for proximity fuse mechanisms. The same stamping dies that produced toy girders could produce fuse components. The same assembly workers who built toy cranes could assemble fuse mechanisms. The same quality control that ensured toys worked properly could ensure fuses detonated accurately. The proximity fuse was one of World War II's most important secret weapons. A small radar device mounted in artillery shells and anti-aircraft rounds, it detected when the projectile came near a target and detonated automatically. This eliminated the need for direct hits or time fuses, dramatically increasing the effectiveness of anti-aircraft fire. But proximity fuses required miniature components manufactured to precise tolerances, assembled carefully, tested thoroughly, and produced by the millions. Each component needed to be small enough to fit inside an artillery shell, rugged enough to survive being fired from a cannon, and reliable enough to detonate at exactly the right moment. Gilbert's Erector set factory was perfect for this. His workers already stamped small steel parts to precise dimensions. They already assembled complex mechanisms from dozens of components. They already tested products to ensure reliability. And they already did all this cheaply enough that families earning $20 per week could afford the result. By March 1942, the Gilbert factory was running 2 shifts. The day shift produced Erector sets using traditional designs. The night shift produced proximity fuse components using modified versions of the same stamping dies and assembly fixtures. Workers who assembled toy construction sets during the day assembled fuse mechanisms at night. The same steel that went into toy girders went into fuse housings. The same precision screws that held toys together held fuses together. The genius of this approach was efficiency. No retooling time was lost, no workers needed retraining, no new supply chains needed establishment. The factory simply added a second product line that shared 80% of its manufacturing processes with the existing toy line. Security was maintained through compartmentalization. Day shift workers knew they were making toys. Night shift workers knew they were making precision instruments for the military, but not specifically what those instruments did. Only a handful of supervisors and engineers knew the complete picture. The components left the factory in unmarked crates, shipped to final assembly facilities where they were integrated into complete proximity fuses. By late 1943, the Gilbert Company was producing proximity fuse components for over 100,000 shells per month while simultaneously maintaining Erector set production. The dual production line meant that if enemy agents observed the factory, they would see a toy manufacturer operating normally. Perfect cover for one of America's most secret weapons programs. In the summer of 1942, British intelligence approached Parker Brothers with an unusual request. They needed maps.
Not ordinary maps, but special maps printed on silk or tissue paper that could be concealed inside board games, hidden in playing cards, or sewn into clothing. Maps that prisoners of war could use to plan escape routes across occupied Europe. Parker Brothers seemed an unlikely choice for such a critical mission, but British intelligence had done their research. The company's printing facilities could reproduce complex multicolored maps with perfect accuracy. Their experience printing Monopoly boards meant they understood how to create detailed images on various materials. And, critically, they had perfected techniques for printing on silk, a skill developed for luxury game boards that turned out to be exactly what was needed for escape maps. The project began with Christopher Clayton Hutton, a British intelligence officer working for MI9, the organization responsible for helping POWs escape. Hutton had already developed various escape aids, compasses hidden in buttons, saws concealed in combs, maps printed on handkerchiefs, but he needed a way to mass-produce maps that could be smuggled into POW camps, hidden inside care packages. Parker Brothers' solution was ingenious. They developed a printing process that could reproduce detailed maps on silk cloth, thin enough to be folded into a package smaller than a deck of cards. The silk was treated with a special coating that made it moisture-resistant and prevented the ink from running when wet. The maps included escape routes, safe houses, and critical information encoded in seemingly innocuous markings. These maps were then concealed inside Monopoly sets sent to POW camps through the International Red Cross. But these weren't ordinary Monopoly games. They were special editions, manufactured specifically for POW camps, with maps hidden inside the board, compasses concealed in game pieces, and real German, French, and Italian currency hidden among the Monopoly money. The special Monopoly sets were marked with a secret code, a tiny red dot in a specific location on the box, that POWs were taught to recognize through coded messages in letters from home. When a prisoner received a Monopoly set with the marking, he knew it contained escape materials. Parker Brothers produced over 35,000 of these modified games during the war. The exact number of successful escapes aided by these maps remains classified, but MI9 records indicate that the silk maps were found in the possession of escaped POWs numerous times. After the war, Hutton estimated that these maps had helped hundreds of Allied personnel evade capture or escape from POW camps. The operation remains so secret that most Parker Brothers employees didn't know what they were printing. The silk maps were produced in a separate, secured area of the factory. Only a handful of workers with security clearances handled the special Monopoly sets. Even company executives weren't informed of the complete operation until after the war.
The Lionel Corporation, America's premier model train manufacturer, possessed capabilities that military procurement officers initially overlooked. Lionel specialized in miniature electric motors, precision metal stamping, and complex assembly of small mechanical parts. These skills, developed to create realistic model trains, translated directly to military applications. In 1942, Lionel received contracts to produce compass bearings for Navy ships. The precision required was extraordinary. Each bearing needed to be machined and assembled to tolerances measured in thousandths of an inch, then tested to ensure accuracy under various conditions. Lionel's experience making miniature train motors that ran smoothly and reliably gave them exactly the expertise needed. But Lionel's most significant contribution came in producing hand navigation compasses for military personnel. These weren't simple Boy Scout compasses. They were precision instruments that needed to be accurate to within 1 degree, remain reliable after being dropped or submerged, operate in temperatures from Arctic cold to tropical heat, and be manufactured by the tens of thousands. Lionel's engineering department adapted techniques from model train production to solve these challenges. The compass housings were stamped using modified train component dies. The assembly process followed procedures developed for train assembly, where multiple small parts needed to fit together precisely. Quality control systems borrowed from train testing ensured every compass met military specifications. The company also produced emergency signaling devices, precision gears for fire control systems, and components for torpedo mechanisms. Each product leveraged specific skills developed in the toy business: metal stamping, precision assembly, quality control, and the ability to produce complex mechanisms cheaply enough for mass production. By 1943, Lionel had converted approximately 80% of its factory space to military production, while maintaining limited toy train production using the remaining capacity. Like Gilbert, Lionel discovered that maintaining some civilian production was actually more efficient than complete conversion, because it kept specialized equipment running and workers trained on core processes. Joshua Lionel Cowan, the company's founder, insisted that Lionel would return to full toy production after the war. He believed that maintaining the company's toy-making capability, even in limited form, was essential for post-war recovery. This decision proved prescient. Lionel was able to resume civilian production far faster than competitors who had completely abandoned toy manufacturing.
The Ideal Toy Company, maker of dolls and plastic toys, possessed expertise in material science that became critical as the war progressed. Ideal specialized in molding various plastics and composite materials, skills that most heavy industry lacked entirely. In 1943, military planners faced a problem with infantry equipment. Traditional materials like wood, metal, and leather were becoming scarce, and their weight burdened soldiers already carrying enormous loads. The military needed lightweight, durable materials that could replace traditional components in everything from rifle stocks to canteen covers. Ideal's research department had spent years developing plastics and composites for toys that needed to be lightweight, durable, washable, and safe for children. These same properties made them ideal for military applications. Ideal began producing molded plastic components for gas masks, experimental plastic rifle stocks, lightweight containers for rations and medical supplies, and prototype materials for a dozen other applications. The company's most significant contribution was developing improved plastic materials for proximity fuse components. Early fuses used components made from materials that were either too heavy, too fragile, or too expensive for mass production. Ideal's plastics engineers developed composite materials that were lightweight, rugged, resistant to temperature extremes, and could be molded quickly and cheaply. These materials innovations extended far beyond military applications. The plastics and composites developed for wartime use became the foundation for post-war consumer products. Modern plastic toys, lightweight consumer goods, and countless other products trace their lineage to materials developed by toy companies solving military problems during World War II.
The toy industry's war contribution extended far beyond individual companies. A hidden network of manufacturers, each contributing specialized capabilities, formed an industrial system that the Axis powers never understood or anticipated. Small companies that made toy soldiers produced precision-cast lead components for electronic systems. Board game manufacturers printed training materials, propaganda leaflets, and specialized documents. Puzzle makers created training aids for aircraft identification and map reading. Even companies that made children's books contributed, using their printing facilities to produce training manuals and technical documents. This network was remarkably efficient because it leveraged existing relationships. Toy companies had established supply chains, understood each other's capabilities, and often collaborated on civilian products. Converting these relationships to military production was far easier than building new industrial networks from scratch. The security advantage was significant.
Enemy intelligence focused on obvious targets: steel mills, aircraft factories, shipyards. Nobody paid attention to toy factories, board game manufacturers, or children's book publishers. These companies could operate with far less security overhead than traditional defense contractors because they were hiding in plain sight. The Office of Strategic Services recognized this advantage and actively recruited toy companies for classified projects. Several companies produced specialized equipment for OSS operations, devices for sabotage, escape and evasion, communication, and intelligence gathering. These devices needed to be small, reliable, easily concealed, and simple to operate, exactly the criteria that made good toys.
What made toy manufacturers so valuable wasn't just their physical capabilities, it was their engineering philosophy. Toy makers approached design problems differently than traditional military contractors, and those differences produced better results in many applications. Toy companies designed for cost. A toy that cost too much wouldn't sell, so every component needed to be as cheap as possible while still functioning reliably. This cost consciousness translated directly to military production, where weapons needed to be affordable enough to produce by the millions. Toy companies designed for simplicity. Complex toys frustrated children and generated returns, so designs needed to be intuitive and self-explanatory. This simplicity made weapons easier to maintain in field conditions and reduced training time. Toy companies designed for durability under rough handling. Children's toys needed to survive being dropped, thrown, left in rain, and generally abused. Weapons needed the same durability, and toy manufacturers already understood how to achieve it. Toy companies designed for reliability without maintenance. Parents wouldn't buy toys that required constant repair, so products needed to work consistently without intervention. Military equipment needed the same reliability, especially in combat conditions where maintenance was difficult or impossible. These design principles, cost consciousness, simplicity, durability, and reliability, weren't emphasized in traditional military contracting, where performance often trumped all other considerations. Toy companies brought a different perspective that produced weapons that were good enough for their purpose, cheap enough to produce in quantity, and reliable enough to work when needed. The proximity fuse, to which Gilbert and other toy manufacturers contributed so significantly, changed warfare fundamentally. Before proximity fuses, anti-aircraft guns had hit rates of around 2,000 rounds per kill against aircraft. With proximity fuses, hit rates improved to around 100 rounds per kill, a 20-fold increase in effectiveness. During the Battle of the Bulge in December 1944, American forces used proximity-fused artillery shells against German ground forces with devastating effect. The fuses detonated shells above ground, creating airburst patterns that were far more deadly than impact-detonated shells. German forces had no defense against this new weapon. Against V-1 flying bombs attacking Britain, proximity-fused anti-aircraft shells increased kill rates from less than 10% to over 70%. British air defenses that had struggled to stop the V-1 campaign suddenly became highly effective. In the Pacific, proximity fuses protected American carriers from kamikaze attacks. The improved effectiveness of anti-aircraft fire meant that fewer kamikazes penetrated carrier defenses, saving ships and lives. By war's end, over 22 million proximity-fused shells had been produced. The toy manufacturer's contribution, producing the precision miniature components that made these fuses work, represented a significant fraction of this total output. And they had accomplished this while continuing to produce toys, maintaining civilian morale, and keeping their businesses viable for post-war reconstruction. The full story of toy manufacturers' war contributions remained classified until the 1960s. Companies that had produced proximity fuse components, escape maps, and classified equipment couldn't discuss their work. Employees who had assembled fuse mechanisms or printed silk maps were sworn to secrecy. When declassification finally occurred, the revelations surprised even industry insiders. The scope of toy industry involvement in weapons production had been far greater than anyone outside the classified programs realized. Nearly every major toy manufacturer had contributed something: components, materials, expertise, or facilities. A.C. Gilbert received official recognition for the Erector Set factory's contribution to proximity fuse production. The company had produced components for over 3 million fuses, while simultaneously maintaining toy production that kept American children entertained during wartime. Parker Brothers' role in producing escape maps was revealed, and surviving POWs confirmed that the silk maps hidden in Monopoly games had helped them evade capture or escape from camps. Lionel Corporation's precision compass production was documented, showing that the company had manufactured over 650,000 military compasses during the war years. The revelations vindicated Harry Antes Gilbert's decision to resist complete conversion to war production. By maintaining toy manufacturing while adding military production, his factory had been more productive than it would have been if completely converted. And by keeping workers trained on precision toy assembly, Gilbert ensured they could immediately resume civilian production when the war ended. The toy industry's war contribution established principles that continue influencing defense procurement today. The idea that civilian industries possess specialized capabilities that can be rapidly adapted to military needs became central to American defense planning. The proximity fuse technology, developed with toy manufacturer participation, evolved into modern smart munitions. Today's precision-guided weapons trace their lineage to the miniature radar systems that toy companies helped produce in 1942 to 1945. The materials science innovations developed by companies like Ideal Toy transformed post-war consumer products. Modern plastics and composites used in everything from automobiles to consumer electronics evolved from materials developed to solve wartime problems. The map printing techniques perfected by Parker Brothers influenced post-war cartography and printing technology. The ability to print detailed, durable maps on various materials became standard in outdoor recreation and professional mapping. Perhaps most importantly, the toy industry's war contribution demonstrated that innovation comes from unexpected places. The same companies that made children's toys proved capable of contributing to the most advanced weapon systems of their era. Their expertise in miniaturization, precision assembly, cost reduction, and reliability translated directly to military applications that traditional defense contractors struggled to master. Behind the statistics and technical achievements were people whose lives were transformed by their unlikely war work. Women who assembled toy trains by day, assembled compass mechanisms by night, earning wages that supported families while husbands served overseas. Engineers who designed erector sets found themselves designing components for proximity fuses, their creativity channeled toward national survival rather than children's entertainment. Harry Antes Gilbert himself faced a difficult decision when the government wanted to commandeer his factory. He could have complied, shut down toy production, and converted completely to military manufacturing. Instead, he argued for a more efficient approach that preserved his company's core capabilities while contributing to victory. His decision required courage. Contradicting government officials during wartime risked being labeled unpatriotic. But Gilbert understood that sometimes the most patriotic choice is the one that questions authorities' assumptions. Factory workers at Parker Brothers who printed Monopoly boards
found themselves printing silk escape maps, knowing that their work might save the lives of captured airmen or soldiers. The psychological weight of this responsibility, combined with the inability to discuss it with anyone outside the secured printing area, created unique pressures that these workers bore silently for decades. Lionel Corporation employees who assembled model trains shifted to assembling precision compasses, knowing that navigation errors could cost lives. The quality control standards for toys, where failure meant disappointed children, became quality control standards for military equipment, where failure meant death. Workers adapted to these higher stakes while maintaining the precision and reliability that made them excellent toy makers in the first place.
Despite their contributions, toy manufacturers received little public recognition during or after the war. Defense contractors like Boeing, Lockheed, and General Motors were celebrated for their war production. Shipyards and steel mills were featured in propaganda films and news reports. But toy factories operated in secrecy, their contributions hidden behind classification and obscurity. This anonymity was partly deliberate, revealing that toy companies produced proximity fuse components would have compromised operational security. Acknowledging that escape maps were hidden in Monopoly games would have endangered POWs who possessed these games. The need for secrecy meant that toy manufacturers couldn't publicize their war work. But the anonymity also reflected cultural assumptions. Toy making wasn't considered serious engineering work. The idea that companies famous for children's entertainment could contribute to advanced weapons development didn't fit comfortable narratives about military-industrial production. Even after declassification, the story of toy makers' war contributions remained largely unknown outside industry circles. The workers who assembled fuse mechanisms and printed escape maps went back to assembling toys and printing game boards after the war ended. They couldn't list their war work on resumes because it remained classified. They couldn't tell their families because they had been sworn to secrecy. They simply returned to normal life, carrying private knowledge that their hands had helped win the war.
Today's defense industry faces challenges similar to those of 1942. Modern warfare demands technologies that traditional defense contractors struggled to provide: artificial intelligence, advanced materials, miniaturization, cost-effective mass production. The Pentagon looks increasingly to commercial technology companies, seeking capabilities that didn't develop within the defense industrial base. The lesson from World War II toy makers remains relevant. Sometimes the best solutions to military problems come from industries that seem completely unrelated. The skills that make a good smartphone, video game, or consumer drone can translate directly to military applications. The challenge is recognizing these connections and creating procurement systems flexible enough to leverage commercial capabilities. During COVID-19, this lesson manifested again when distilleries converted to producing hand sanitizer, clothing manufacturers made masks, and automobile plants built ventilators. The ability of civilian industry to rapidly adapt to crisis needs, demonstrated so dramatically during World War II, proved essential once more. The toy industry's war contribution offers a template: identify specialized capabilities in unexpected places, leverage existing infrastructure and expertise rather than building from scratch, maintain flexibility to resume civilian production, and recognize that good enough, produced in quantity, often beats perfect, available in limited numbers.
The toy factory that helped win World War II wasn't a single facility. It was an entire industry that discovered its hidden potential when crisis demanded innovation. From A.C. Gilbert's Erector Set factory producing proximity fuse components, to Parker Brothers printing escape maps, to Lionel manufacturing precision compasses, America's toy makers contributed capabilities that traditional defense contractors couldn't match.
They succeeded not despite being toy makers, but because they were toy makers. Their expertise in miniaturization, precision assembly, cost reduction, and reliable mass production translated directly to military applications. Their engineering philosophy, designing for cost, simplicity, durability, and reliability, produced weapons that worked better and cost less than traditional military designs. The story remained hidden for decades, buried under classification, and obscured by assumptions that toy-making wasn't serious engineering. But the evidence is clear. Proximity fuses that devastated Axis forces contained components stamped in the same dies that made Erector Sets. Escape maps that helped POWs evade capture were printed on the same presses that made Monopoly boards. Compasses that guided soldiers and sailors to safety were assembled by workers who built model trains. When Japanese admirals laughed at American industrial capacity, they were thinking about steel mills and shipyards. They weren't thinking about toy factories. That oversight was fatal. The weapons that helped defeat the Axis powers came not just from obvious sources, but from the hidden capabilities of industries that seemed irrelevant to modern warfare. The toy makers who secretly helped win World War II proved that innovation comes from unexpected places, that civilian capabilities can be rapidly adapted to military needs, and that sometimes the best weapon is the one nobody expected would work at all.